This puzzle is called Whispers in the Fog by JayForty. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look at the rules. A single snake moves orthogonally through the grid without branching or entering the same cell twice. It is marked as a green line. Okay, so this green line will go, whoops, not like that. Orthogonally means just side to side, like it won't go diagonally, it'll just connect by the sides, like how you see it going here. So that means this line is going to go some way, uh, some wild way like this. Let's say, there we go. Yeah, adjacent digits along the snake have a difference of 5 or more. So it's a German whisper line. That's the official name for it. So, like we have this digit here. Let's say this is a 2. Oh, I really shouldn't use big numbers. Because this is also a fog of war puzzle, obviously. Which I'll explain in a second since it doesn't say here, but let's say this is a 2, then these digits would both have to be 5 or more away from it, which would mean they would have to be 7, 8, or 9. Yeah, that's all there is to that. And of course, yeah, I mean, that just keeps going like that they keep having to repeat, or they keep having to stay 5 away from each other all the way along, of course. An inequality sign between two digits points towards the lower digit, so this digit is lower than this digit. The way I learned about it is it's like an alligator with its mouth open, and it eats the bigger digit because it's hungry. So if this digit was a 4, this digit would have to be less than a 4, for example. Pretty easy, simple thing there. Cells separated by a black dot contain digits in a 1 to 2 ratio. We don't have any black dots showing at the moment. Let's pretend that there was a black dot between this and this cell, these two cells. So if like this one was a 3, we would have to put a 6 in here so that there would be a ratio of 1 to 2. That means one of the two digits is double the other one. So if there was a black dot in between these two cells, this is a 3, we would need to put a 6 in here. Because you can't do 1.5, even though that's a 1 to 2 ratio with 3, 1.5 is not valid entry into Sudoku, obviously. But if this was a 4, for example, this could be a 2 or an 8, because 2 times 2 is 4, and 4 times 2 is 8. Those both work. Oh, and then Fog of War. So obviously we can't see most of the grid. But we'll figure out digits along the way as we go. And it will reveal more of the grid. So let's say we found out that this was a 5. That would illuminate all 9 of these cells. Once we got that 5. Or if we get this digit, it would illuminate all of these. And we already know some of them, but that's okay. I think that's everything. I'll put a link to the puzzle down below in the description if you want to give it a try yourself. I don't know how hard this is, but we'll get going. So, I guess we need to talk about German whisper lines. The first thing that we need to talk about is 5s. 5 can never go on a German whisper line. If we tried to put a 5 here, for example, or even on the end of the line, let's try to put a 5 here, this digit would have to be a 0 or less, because obviously 5 minus 5 is 0, or 10 or more, because 5 plus 5 is 10. And of course, there are no digits in Sudoku that are 0 or less, or 10 or more, so 5 cannot go on a line, so we can kind of limit that. The next thing kind of follows from that is that digits oscillate back and forth from a high digit to low digit to high digit to low digit and so on. Because we can never have a 5. One digit, if we find out that one digit is lower than a 5, we'll just call that blue. One digit is lower than a 5, let's say it's a 3, then the next digits will both be higher than 5. Let's do red. So this will be an 8 or an, whoops. This will be an 8 or a 9, and this will be a low digit again, because even 9 minus 5 is 4, which is, again, a low digit. So it just keeps on swapping back and forth like that. Now, we don't know any specific digit. Like, we couldn't say, oh, this is a low digit, like, this is a low or a high digit. We don't know yet. but it is important to remember that eventually we'll be able to know that the digits will be high and low. And actually, I think there's another trick to the snake. So it's really easy to say, like, let's say we don't know which is high, which is low. So let's do orange and the orange and yellow is probably too close. Orange and pink maybe, or probably more different. Hopefully those are different enough. Or maybe I can do, yeah, maybe pink or purplish, whatever this color is, and yellow. Those are pretty different. So we have these two colors. We don't know if purple is high or low, but we do know that obviously they're not the same because we have to do that kind of switching back and forth thing. So we actually know we can keep drawing the line like this. The line must go in there. We don't know where it goes from there, but we know it goes that much at least. What was I saying? Oh, yeah, sorry. So you can kind of see, obviously, that there's swapping back and forth, but because the line never goes diagonally, we're going to get this checkerboard pattern on the grid, where we actually know the kind of polarity, I guess, of this digit. So no matter how we move around the grid, so let me just do an example here. So let's say we move around, I'm just gonna do all randomly, not, whoops, not diagonally, but let's just say like that. And then we come in and we color this. We're gonna find that this is purple because it's gonna end up being this checkerboard thing. So every other cell is purple. There we go, yeah. Every other cell is purple, so it's impossible to have two yellows adjacent to each other or two purples adjacent to each other because you have to move twice in order to get purples, and you can never move twice and only end up one cell away from it. You can never do, like, let's say 6 moves, a multiple of 2, and end up right here. 1, 2, 3, 4, 5. That's 5 moves. I was thinking it is 6 cells highlighted, but it's only 5 moves. Now, obviously, we don't know that the line goes exactly in this way. But it does mean that this is going to be purple, and this is going to be yellow, this is going to be purple, this is going to be yellow. This checkerboarding doesn't apply to unlined, I guess, unlined? I guess that's good a term as any. Unlined cells, but we do know that these unlined cells are either, we need a different, I usually use gray for 5 in these puzzles, but with the fog, that might not be the best color. I guess we'll go like this. We'll just leave 5s as unshaded. We do know that the unlined cells in this box are going to be either yellow cells or 5. And we know that because we already have 4 purples, and you can only have 4 lows or 4 highs within a row, column, or box. So we already have all 4 purples for box 8. That means that means the rest must be yellows or 5s. So these are all yellows and 5s. Now, purple is less than yellow. That would imply that purple is a low digit. Because obviously you could never have, let's say, a 6 being greater than a 4. Like that wouldn't work. So if this is a yellow digit, purple must be low. What if it's a 5? Well, if it's a 5, it also must be low because low digits by definition are less than 5. So it actually turns out that purples are low and yellows are high. So let's just swap those really quickly. Actually, you know what? Maybe I'll switch to orange. No, let's go with red. Red for high, blue for low. And I'm gonna actually get rid of this coloring. Whoop. I don't know how helpful that is. Okay, so what does that mean? Okay, so that means that we need to have 1, 2, 3, and 4 be on these lines, and these digits are 6, 7, 8, and 9. Now, we already talked about 5 being restricted, as in they can't be on the line, 5s can't be on the line at all, but 4 and 6 are actually very restricted as well. Not quite as much, but close. A 6, let's say we try to make this a 6. What digit goes next to a 6 on the line? Well, 6 minus 5 is 1, so okay, we could put a 1 here, but now what goes here? It would also have to be a 1. That's not possible. Um, we can't have two 1s in the same box, of course. The digits can repeat on the line and will repeat on the line because it's going to go all over the grid, but within the same box or row or column, they can't repeat. So we couldn't put a 6 part way across the line if both adjacent digits see each other like this. So this can't be a 6. Same with this, that would put two 1s right here. But now, more importantly, let's look at the low digits. If we put a 4 right here, what happens? Well, 4 plus 5 is 9, so both of these would have to be 9. That's not going to work. So we can remove 4 there. Same thing happens here. Same thing happens here. So this is a 4. This is the last spot. I mean, we've ruled 4 out of every other spot, so this must be a 4. Now, what can be adjacent to 4? We just said it must be a 9, so let's put a 9 there. There we go. And this can't be a 9. Okay, 1 second. Sorry, my throat is a little scratchy, so I have to clear my throat a little bit. So what can be in this line, or sorry, in this cell? So we can keep coloring a little bit, can't we? Because of the checkerboard thing that I was talking about, this must be blue, this must be red, and actually I'm going to remove this line. I don't like the doubledness of the green line. Looks a little weird to me. Okay, so let's look at this line right here, or sorry, this black dot right here. What could be on this black dot? Could we ever have a 7 or a 9 along the black dot? Well, no. If you double 7, it goes to 14. If you double 9, it goes to 18. Those digits can't be in a Sudoku. If you try to have either one of them, you go to 3.5 or 4.5, and again, those don't go in a Sudoku, so this is just 6 or 8. So this needs to either be double 6 or double 8 or half 6 or half 8. You can't double them because those would be too big, so this is a 3 or a 4. We have a 4 right here. This is a 3. This is a 6. This is a blue. This is a red. Okay, I just see that 6 must go over here in box 8 because it can't go right here. 3 must go to 8 or 9, so this is an 8 or 9, and actually, of course, the last thing I see is the most important, is that 6 can only connect to 1. We talked about that, so this is a 1, this is a 1. This line is going to extend a little bit. Blue, and then red. And let me reread. So it's a single snake going around the grid. So if we make this line go upwards, where does this line go? This line can't go anywhere. So this line would be done. But we already have two ends of the line. We have an end of the line right here and an end right here. Which means that, yeah, this isn't going to work. We would have 3 snake tails, I guess, or snake heads, whichever way you want to look at it. But you need one snake, and if it never, without branching or entering the same cell twice, yeah, that's never going to happen. So this line must come down. And then it must come down again because it can't go this way, because we would see it if it went that way. Now we don't know if it goes like this or if it just goes like this, but it will do one of those two things. Yeah. So this is, I guess these are 2 or 4s. We know 5 is in one of these 2 cells. Because we can't put a 5 on the line, of course. Whoops. Can't put a 5 on the line, of course. This is a 7, 8, or 9. This is a 6, 7, 8. These are 1, 2, 3s. Oh, this can't be a 4. Oh, yeah, this can't be a 4. If this was a 4, this would be a 9, and this sees a 9 already. So this is just a 2. Oh, so this is a 4, which is going to make both of these 9. Let's get rid of the... I don't like that double line. I've talked about that. Let's get rid of the double lineness. Okay. Now we have a lot more. So these are red. These are blue. And actually, I forgot this is also blue, and these are also red. Because of course we can tell where the line is going. Okay, no, I was gonna say this must connect down here, but that's not true. This could go like this, or it could even go like that. But this must go up. Because again, if it went down, then we're gonna end up with another like snake tail, when we already have both of them, so it must go up, and then I guess it must go up again because it can't come right. So this is red, this is blue. This one can go in either direction just fine, I think. This is a 7 or an 8. If we said 5 must be in here, this can't be a 5. This is a 5. Yeah, okay. So this is a high digit then, because this is a high digit. Because we had all 4 low digits, so now we need all the high digits. And neither of these can be 6. If we tried to put a 6 in either one of these cells, either both of these would be 1, or both of these would be 1, and in which case we'd break the rules by having way too many 1s. So this is a 6. And this is going to be a high digit eventually, once we figure out how that connects. And these are low digits. Okay. Okay, what else can we do? Okay, so this can't be a 2. This can't be a 6 because that would need 1s, of course. Oh, this can't be a 1, so this can't be a 6. This can't be a 1, this can't be a 1. This can't be a 6. So we actually haven't put 6 in the bottom row. That might be important to think about. We haven't done... Actually, I guess we can kind of type it in. We haven't done 4, 6, 1, or 5. Yeah. And maybe that's not as helpful as I thought it might be, but whatever. No harm in typing that out. So these... Oh, this can't be a 9. These can't be... Or these are 7 or 8. These are 1, 2, and 3. Now this can't be a 6 because I would put 2 1s. So this is 7, 8, 9. This could be a 6, though. Both of these could be 1s just fine. This can't be a 1, and it can't be a 4, so it's a 2 or a 3. Because if it was a 4, both of these would be 9, of course. Sorry about that. My nose got a little runny, and you need to take care of that with the microphone off. You're very welcome for that. You did not want to hear me blow my nose. Okay, this is a 7, 8, or a 9, because it can't be a 6. Okay, there's some other deduction here that... Well, this can't be a 6, so this is a 7, 8, or a 9. We do have a 7, 8, and 9 triple here. I don't know how helpful that is. This is a 1 or a 2. I didn't notice that. That could be important. Though, no, that could still be 7 or... If this was a 7, that would be a big deal. Oh, we do have a 1, 2, 3 triple there. Which means 3 is in the middle here. I guess that means this isn't a 3. One of these two is a 3. If this was a 3, this would be 8, 9. If this is a 3, this would be 8, 9. I think both of those are equally fine. Oh yeah, this couldn't have been a 3 anyway, because one of these two digits will be a 7, and you can't have a 3 next to a 7. What was the last thing I did that was like real progress? Was it the 6? Yeah, it was the 6. Okay, so far at least, like each thing we've done has pretty much directly led to the next piece of logic, which is often how fog of war puzzles work. So let's try to focus our looking up here. Maybe there's something I'm just not seeing up here. This can't be a 9. Obviously, there's a 9 right there next to it, or not next to it, near it, in the column. Well, this can't be a 9 either. Oh, that makes this a 9. That makes this not a 9. We know this isn't a line, so we know the line goes there. Okay, so now we know that this is not a 3. If this was a 3, both of these would have to be 8 or more, and one of them is going to be a 7, so this is a 1. Let's get rid of these icky double lines. These can't be 1, so one of these is a 1 over here. Hmm. Yeah, I was saying if this is a 7, this is a 2, 1, which puts a 1 here, but that doesn't quite help. Oh, I never marked this early. One of these is a 6, because we have this 6 and then the 6 along here. But that doesn't seem super important. 4 is in one of these spots, that's fine. 9 is in one of those 2 spots, that's a little restricted, although 9 is unfortunately one of the least restricted, along with 1 along the line itself. I keep wanting this 3, 4, and 1 to like all see the same cell, but that's just not really possible. Like if this 3 could see this, that would help, greatly. Oh, this can't be a 3. I've said this a couple times. One of these is going to be a 7, so this can't be a 3, this is just a 2. Which is going to figure out how this line works, which is very nice. So this is a 1, 2, or a 3, because it can't be a 4. We now have a 1, 2, 3 triple, so these are both 5s, or a high digit. 5, 6, 7, 8. This is a 3, then of course this is an 8, and this is the 7. This can't be a 3, this can't be a 7, this can't be a 7. Or those being the 7. Those also can't be 7s. Oh, there's a 1 right over here. There's a 1 right here, making this a 2, which makes this a 3. Makes this an 8, makes this a 7. And this is 7, and this an 8, and this a 9. And this is 7. So this can't be a 3, this can't be a 7. This is the 3. This has to be 1, 2, which it already is. Oh, this is a 3, so this must be an 8. Okay, so we loop around like this. This is a 1, 3, or 4. Actually, it can't be a 4 since we can't put an 8. Sorry, since we can't put a 9 there. So it's a 1 or a 3. No, it can't be a 3. If this was a 3, this would have to be an 8 or a 9. So it would be an 8 because it can't be 9. Now this has to be an 8 or a 9 as well. Let's just use the quarter markings really quickly just to show the symbol, or just show the digit. If this was a 3, this would have to be an 8 because it can't be a 9. And this can't be, oh, this can't be an 8 or a 9. Never mind, that's easier than I even thought it was. I thought it was, we were going to end up in with 8 in both of these cells, but this can't be either of them. So this is just a 1. Let's get rid of that real quick. And this is just 6 or 7. Just get rid of that. I don't think that's helpful. And 6 or 7 is fine with a 1, 2 here. I mean, everything's fine with a 1. 1 can go with any high digit. Well, we know this is a high digit. Come on. There we go. Oh, this must be a 7. We have 6, 7, 8 in the column. There we go. So these are 3, 4, or 5, because they can't be high digits because we have 6, 7, 8, 9 in the column, and it can't be 1 or 2. So it's either a low digit or a 5. If it's a low digit, it's a 3 or a 4. If it's a 5, well, then it's a 5. Okay. Oh, is that the full line then? Huh. I kind of expected the line to go everywhere. Maybe there's just is there enough already to do the Sudoku? I didn't realize that. Okay. One of these is a 2. Oh, this is just a 3. That doesn't super help. I guess neither of these are 3, so that's a 4, 5 pair. That makes that a 1, makes that a 2, 1, 2, 1. That makes this not a 5, which makes this a 5, which makes that not a 5. That's a 9 then, because we have a 6, 8 pair. And this is a 3. What are these? This is 4, 6, and 8. This can't be an 8, so this must be the 8. This can't be a 4 because of the 4 there. These are high digits. These are... Oh, actually, these are low digits. I didn't even see that there. What do we have left in here? That's 5, 6, and 7. This can't be a 5. Oh, this must be the 6. We have a 6 looking over here. Those can't be 4. This is a high digit. So this is a 2 and a 4 in here. Those are both low digits. Oh, here we go. This is just a 2 because we have a 1 right there that I totally missed. That makes this a 7. This can comfortably be a 6, but it doesn't have to be. It could be an 8. But we already have the 1s ready if it's a 6. That's actually the last digit on the line. Didn't expect the line to be done so quickly. Like, compared to the rest of the puzzle. 6 and a 5 is what's left. What's in here? We need a 7. The 7 must go here because of this 7. 4, 5. Okay, let's keep looking. We need a 9, we need a 4, and we need a 5. A lot of 4, 5s around, or 5, 6s. What about here? We need a 3, an 8, and a 6. This can't be a 3, this can't be an 8. That makes this a high digit. Okay, what about here? We need a 4, 5, we need a 7. Oh, we have a 7 right here. What am I talking about? So this is 4, 5, and 3. And the 3 must go here. Oh, we have a 4, 5 pair now, so this can't be a 5. This is a 6, this is a 5, this is a 4. And that's going to resolve. We just finished the line. We just figured that out. Okay, let's color a few things. Just keep up with that. This is a 2, 8, 9. This can't be a 9, can't be a 2, can't be an 8. This is always a high digit at least. Okay, well 1 goes right here. 1, 1, 1, 1. Whoops, 1, 1. 1's looking in. Okay, so we have this black dot. Okay, so what... Every black dot must have a low digit on it. Because if you try to double a high digit, you're gonna get way too big. Just by definition. If you double a 6, you get 12, so that doesn't work. So you have to have the larger digit or have 2 small digits. But you have to have at least 1 small digit. And we've already used 1, 2, and 3, so that's 4, 8 is all that remains. That makes this an 8, makes this 4, and is going to finish off the puzzle, I think. Not too difficult overall. That was a fun puzzle, though. It definitely there was a lot of logic at the beginning to just kind of understand how the puzzle works in general. With the German Whisper line and the checkerboarding, and then I guess understanding how German Whispers work in the first place has a lot of just like not obvious logic that you just kind of learn by doing, or being told, I guess, what's the other option. There we go. Let's color these last 2 cells, and we finished it. That was a lot of fun, but that was definitely tricky. Probably like a 2.5 out of 5, maybe. I think difficulty. Once you started going, it wasn't too bad. Or it wasn't too hard, I mean. But yeah, there was a lot of stuff you kind of had to figure out about just the nature of how the puzzle works in total at the very start before you can even see very much, which can be a bit daunting. But yeah, that was a lot of fun. Oh, I didn't even notice that little Christmas hat up there. That's cute. Yeah, so thank you for the puzzle, JayForty, and thank you all for watching.